Okay guys, this is going to be a video, first video to discuss the urinary system. So before we can talk about the urinary system in depth, we want to just talk about its general functions. So for the most part, people are familiar with the urinary system in terms of filtration and producing urine. But what are some of the other functions that it does? So we're thinking about our urinary system, right? We're thinking excretory, renal, right? What are some of the other functions that are involved aside from producing waste? And that's the one it's famous for. However, there are some very important functions that are a bit less famous. So, pH balance, fluid balance, and osmoregulation plays a huge role in blood pressure control. And then also electrolyte balances. Specifically, we want to think about sodium and potassium, of course. They always have to be a part of the conversation. So, all of these are functions of your urinary system. So this one we'll cover first because it's pretty straightforward. So, when we're talking about fluid balance, that process or that concept is called osmoregulation. So we really have to balance what fluids coming in and fluids going out. You want that net to be zero, okay? So you have areas where you gain water and areas where you lose water. So you think about some potential areas of gain. You would think about your intake with, you can drink, you can eat foods that contain fluid, right? And then your metabolic function. There are chemical reactions that yield a molecule of water, and there are some that consume a molecule of water. We're going to just pretend that nets out at zero, like, right, they cancel each other out. So then what are some of the ways that you lose water? Okay, so since we're talking about urinary system, we'll put that one at the top of the list, would be your urine, of course, but also things like sweating, right, feces. Even though your feces is semi-solid, it does have some water to it. And then, of course, evaporation. The surface of your lungs, remember your lungs are wet, right? The surface of your lungs, though, is exposed to the air that you breathe. So because of that, there's going to be some inherent evaporation at the surface of your lungs. And obviously, this one you have absolutely no control over, okay? And it's a constant. And then you also have loss of water through metabolism. But we're going to just say that these two kind of cancel each other out. So we certainly have more avenues where we can lose water than avenues where we gain water. So we have to make sure that intake matches loss. And that's because we want to prevent dehydration. And though we don't often think about it this way, dehydration kills lots of people every single day. Okay, so now we want to just touch upon the waste piece. Okay, so way back in AMP1 when you learned biomolecules, you learned about things like protein and carbohydrate and fat as the main resources in terms of intake of nutrients. Okay, so we can talk about something being used, right, consumed, and then is there anything left over that we have to deal with? So for example, with carbohydrate, you basically consume most of the carbohydrates that you take in. You don't store a tremendous amount. If anything is stored, it's stored in the form of fat, right? Fat is used for a variety of different things. Building blocks for cells, it's used to produce hormones, and then proteins the same. Proteins are used to build hair and skin and nails and muscles, etc. Okay? Most of those compounds contain carbon, hydrogen, and oxygen in some configuration. But one of the things that protein also contains is nitrogen. And nitrogen is a problem, okay? So your kidneys play a role in getting rid of nitrogenous waste. So obviously, this is waste that contains nitrogen. So nitrogenous waste comes in 3 different forms. Now, before I discuss the three forms, which I will do very quickly, I want to mention that your liver is in charge of producing nitrogenous waste. So that's in charge, which is why you can look at blood ammonia levels as a measure of liver function. So your liver takes charge of production, but your kidney has to take charge of getting rid of it, okay? There's three forms of nitrogenous waste, and I'm going to talk about the advantages and disadvantages of both. That being said, we don't make a third, but we have the capability to produce all kinds. So we have ammonia, we have urea, and we have uric acid. Okay, so we have 1, 2, 3. These are slightly different in their structural presentation, but there's some issues associated with all of them. So we have the capability to make all three, but we don't make them in equal amounts for reasons that will become clear in a second. So first off, I'm going to talk about ammonia, okay? And we're going to talk about it in terms of almost like a cost-benefit analysis. So ammonia is cheap to produce, meaning you don't invest a lot on the upfront from an ATP perspective to make ammonia, okay? So it's cheap from a production standpoint. However, it's really toxic, which is why we don't go to ShopRite and drink a bottle of ammonia, because it'll kill us, all right? The pH is like 12. So it's not something we could carry around in our blood plasma for long periods of time because of its toxicity, okay? So then we have urea. Urea costs you a little bit more money to produce, right? You're putting up more ATP to produce it, so it's a little more work. However, the toxicity is dialed back a little bit. Okay, so we need to hit the sweet spot between what we're spending, okay, and toxicity. And urea pretty much does that. Now, it's not completely non-toxic, okay? It still could kill you. So then you have uric acid. Uric acid is the most expensive from a production standpoint. It's going to cost you a lot of ATP, a lot of money. However, it's the least toxic. However, so we think, well, why don't we just make that one? Because it costs you a lot from an ATP perspective. It's more work. So uric acid, high levels of that are linked to a condition called gout, which we won't discuss. That's something you'll discuss more when you take like a patho type course. So uric acid is linked to a condition called gout. Okay, some people are familiar with that. So we make some of this, you make some of this, but this is the winner. Of the nitrogenous waste we produce the most urea. For reasons that should make some sense now, right? Again, you got to hit that sweet spot between cost up front and toxicity. Okay, so now that we've talked about some of the functions of the urinary system, I'm going to introduce the players of the urinary system, just so we're familiar with who's at the party. All right, your urinary system starts with your kidneys. You have 2 of those. Your kidney's job essentially is to filter blood and create urine from that blood, okay? And we're going to talk about the whole filtration process in our next video. So you have 2 kidneys. Your kidneys are located, pretty high up in your back. They are retroperitoneal, so they're outside the peritoneal cavity. They're not in the greatest real estate, to be honest. They're not really all that well protected by your rib cage. They're kind of halfway in and out. So we wrap our kidneys with a very thick layer of fat to protect them from any sharp blows or injury, okay? I didn't design it. Your 2 kidneys, okay, each one has a ureter. The ureter is just a long tube. Remember, your kidneys are way up here, but your bladder's in your pelvic cavity. So these are 2 long tubes that have smooth muscle in the wall of that tube. So we can use peristalsis to kind of massage urine from your kidneys through the ureter towards the bladder. So you have 2 of these, 2 of those, leading into one bladder, okay? So you see a lot of this 2-2-1 thing with the female reproductive system, right? 2 ovaries, 2 fallopian tubes, 1 uterus. You have it in the male reproductive system as well. So this is a pretty common pattern in our biological makeup. So the bladder is a site where you're going to store urine, and then eventually we're going to contract the wall of the bladder and we're going to have the ability to expel urine as well. Your bladder is a collapsible sac, so it fills up with urine as you're producing it during the day. You fill, As your bladder stretches, it will stimulate receptors that will fire to what's called your micturition area of your brain. That will tell you it's time to find a toilet or tree or something because we got to urinate. The bladder will connect to the urethra, and then that's going to take you to the outside world. The urethra is different for males and females in terms of its length. In females, the size of the urethra is fixed, right? It's pretty much the same from person to person, and is completely separate from your reproductive system. In males, the length of the urethra, because it's threaded through the penis, okay, differs a little bit from male to male. Plus, you think about the shaft and the head of the penis, right? But there's also a whole piece of the urethra and the root of the penis that's embedded in the pelvic cavity, so it's quite long, actually. So the other thing about the male system is the urethra is a shared structure, right? So you have semen or urine coming through there. So we have some issues associated with that we discussed when we discussed the reproductive system. This creates a challenge for men when they have to pass a kidney stone, which is why for some men would argue that it's more painful for a man to pass a kidney stone versus a woman. I don't know if I believe that argument, but certainly the journey to pass the stone is longer than it is in females. Okay. What controls the passage of urine out of the body? Just like when we discussed the anal sphincters, you're going to have urethral sphincters that work kind of in the same fashion. They'll open and close. When they open, urine can pass through. When they close, you may be collecting urine in your bladder, for example. And so those sphincters are made of smooth muscle and skeletal muscle, just like it was set up in the anal canal. So you have control over your external urethral sphincter because it is skeletal muscle. And the advantage there is it gives you control over when you void your bladder to a point. Okay, you fill it up beyond its capacity. The sphincters are just going to pop open from pressure and you pee your pants. All right, the next video, we're going to talk about the filtration system.